All right, so let's take a look at factoring when a is larger than 1. Now, when I say a, I'm talking about standard form of a quadratic is ax squared plus bx plus c. So whatever's in front of or the coefficient of x squared is our a. And if there's nothing written there, we can assume it's 1, which makes factoring really delightful, actually. But when a is bigger than 1, like in this case, we're going to have to take more steps. So what we'll do is we will take a times c. 8 times 9, which is 72. We're going to look for two numbers that multiply to 72 but add to 18. So let's start with 1 times 72, 2 times 36, 3 times 24, 4 times 18, I think. 18 times 4, yep. Are we there yet? I don't think we are. It's not going to go into 5. How about 6? 6 times 12? There it is. That's the one we're looking for. They're going to have to add to 18. So that's 6 and 12. Excuse me. So let's split 18x up excuse me, into 6x and 12x. Basically what we just did was turn our 3 terms into 4, but it's still congruent terms to what we started with. So what we're going to do next is we are going to split this right down the middle, and we're going to find the GCF of the left-hand side, and we're going to find the GCF of the right-hand side. Now, on my left-hand side, I know that 8 and 6 are both divisible by 2, and x squared and x are both divisible by x. What that would leave me with would be 4x plus 3. Now, our goal when we take the GCF of the other side is that in our parentheses, we also end up with 4x plus 3. So let's try it out. The GCF of 12 and 9 is positive 3, right? So we'd be left with 4x plus 3 if we divided both of those, and that's a good sign because this 4x plus 3 and this 4x plus 3 match, and that means that hopefully we did it right. So let's write the 4x plus 3 out as one of our factors, and then whatever did not get factored, the 2x and the plus 3, not factored into the parentheses, 2x plus 3, that's going to become our other factor. And we'd be finished. Okay, now number 5 looks super complicated, and a lot of people shy away from this one, but it's really honestly one of the easier ones. I'm actually just going to make my pen a little smaller. There we go. Okay. So this is something called difference of squares. And let's break that down. The word difference means subtraction, and squares, we're talking about perfect squares. So we have a subtraction sign right in the middle, and 100b squared and 81 are both perfect squares. When we see difference of squares, we're going to use a little shortcut. Now you can go ahead and do all the steps that we just did above, knowing that we have no b term, so it's got to add to 0 instead of 18 like up here. Or what you can do is you can start by drawing 2 sets of parentheses, put a plus in one and a minus in the other, and then take the square root of the first term, 10b, and put it at the start of both parentheses, and take the square root of the second term and put it at the back end of each one of these, and we're done. 10b plus 9 times 10b minus 9. And if you think about it, it really does make sense because the middle two terms, one will be positive 90b and one would be negative 90b, and they would cancel, leaving you with two terms, both are perfect squares, the last one being negative, and difference of squares. There we go.